Hello and welcome to section 9.3, simplifying expressions using the laws of exponents. So first off, we're going to do a quick recap of the different laws of exponents. We have our zero exponent property, where anything raised to the zero power equals 1. Negative exponent, when you have a negative exponent, you move your term to the other side of the fraction and it becomes a positive exponent. The product rule, when you are multiplying with the same base, you keep that base and add the exponents. Quotient rule, when you are dividing with the same base, you keep the base and subtract the exponents. Power rule, taking an exponent raised to another exponent, you're going to multiply. Product and quotient to a power are basically distributing your exponent. For a problem to be simplified, you can only have positive exponents. There are no more power to a powers, so no exponent raised to another exponent. And each base occurs only once, so that if it's a variable, there's only one of each variable left. To solve some examples, what we have that's different in this chapter versus when we've done this before is the exponents are fractions, and so we need to work with fractions, whether you have a calculator with a fraction key on it, that will make life a lot easier. Otherwise, you're working by hand with rules for fractions. So letter A, we have bases of 16 being multiplied together. So I'm going to add the exponents. And when I add these, you would have to have common denominators. So it's going to be 9 over 6. But that's not simplified, 9 over 6, so we need to simplify the fraction. And when we divide by 3, we get 3 over 2. Part B is a fraction, so we have the quotient rule. I'm going to subtract. I'm going to take 2/3 minus negative 5/6, which ends up actually adding. So it's going to be 4 to the 2/3 plus 5/6, and we already know 2/3 plus 5/6 equals 3/2. Now I circled these as answers, but now that I think about it, we should probably take this a little bit farther. So I'm going to back up, and I'm going to actually solve out the problems all the way. So I'm going to take 16 to the 3/2, and I'm going to rewrite it as the square root of 16 to the 3rd power. The square root of 16 is 4, and 4 to the 3rd equals 64. So actually 64 is the answer we're going for. On part B, rewrite it as the square root of 4 to the 3rd power. So it's going to be 2 to the 3rd. Final answer is 8. Part C, power to a power, so we're going to go ahead and multiply 3/2 times 5/3. Those 3's are going to cancel. So I have 4 to the 5/2. Change that to the square root of 4 to the 5th power. 2 to the 5th equals 32. Part D, distribute the exponent. So I'm going to multiply negative 3/2 times 8 over 1. And 1/4 times 8 over 1. So I'm going to have a to the negative 12th, b squared. But I'm not done yet because I can't leave a negative exponent. So the negative exponent is on the a, so the a moves to the denominator. B stays where it is as part of the numerator. Letter E. First thing I'm going to do is distribute. So I'm not going to do anything with the first parentheses yet. I'm going to distribute. So I have 2 times 4/3. Oops. And 1/2 times 4/3. And that's a y. Then I'm going to use the product rule and put my like variables together. So I have x to the negative 4/3 plus 8/3, putting my x's together, and y to the -2 plus 2/3. So I get x to the 4/3, y to the negative. So if I had a common denominator, that would be 6/3, so -4/3. But we're not done yet because we cannot leave a negative exponent as part of our answer. So the y to the 4/3 moves to the denominator. Part F, distribute the exponent in the numerator. 2 to the 5th, x to the -5, y is just going to be squared. Of y squared over y squared, that's going to cancel. And then I have 2 to the 5th is 32. With the quotient rule, it's -5 minus 2, subtracting the exponents of the x. And that turns into -7, which I can't leave that as a negative exponent. So it's 32 over x to the 7th power. When we are working with radical expressions, those are expressions with the square root sign in them, the first thing we're going to do is we're going to change to rational exponents as we simplify it. So to use rational exponents to simplify this radical, I'm going to change it to a fractional exponent or a rational exponent, simplify the fraction, and then put it back into radical form. So because I started with a radical, I'm going to end with a radical. Part B, my exponent as a fraction is 1/3. So I'm going to distribute the 1/3 exponent. When I multiply 3 times 1/3, I just get 1, and 9 times 1/3 is 3. And then I'm going to solve out the 27. So that is the cube root of -27. And the cube root of -27 is -3. Part C, changing to rational exponents using the quotient rule, taking 3/4 minus 1/2 and putting it back in radical notation. Letter D, I have a square root of a cube root of n, so I have, starting on the inside, n to the 1/3 takes care of the cube root, and the square root is 1/2. So I multiply those, I get n to the 1/6, which is the 6th root of n. The next two problems are kind of similar to one another. We have this big expression. It says simplify it by factoring out, and we're told to factor out the common expression x to the 1/2. So factoring is just dividing. So I'm going to divide each term by x to the 1/2. And when I do that, I'm going to subtract the exponents. It's just going to be 3x. And then those x to the 1/2 are going to cancel. So it's going to be 2 times 4x plus 1. And then I'm going to go ahead and distribute and combine like terms. So that's going to be 8x plus 2. So when I combine like terms, I get 11x plus 2. And then on example 4, we're factoring out x minus 5 to the 1/2. So we're going to divide by x minus 5 to the 1/2. So these cancel out. So I have 3 times 3x plus 1. And here when I subtract, it's just the first 3/2 minus 1/2 is 1. So I'm going to distribute. And combine like terms. Actually, one more step. I just realized 15 and 27 have a common factor of 3. So let's factor that 3 out as well. So we'll go with this one here for our final answer.